Okay, so question says multiply these matrices together, and we're going to check to see if associative property is met or not. So first, let's check A multiplied by BC. Okay, so my A is 1 minus 2, 2 negative 1. Then I have B and C in parentheses. So note that here you have 2 rows and 3 columns. And here you have 1, 2, 3 rows and obviously 2 columns. So since 3 and 3 are the same, I expect to get a 2 by 2 matrix. Very good. So here we go. I have 1, negative 2, 2, negative 1. And here this new matrix, let's just write each one down. 1 times negative 1, negative 1. 0 times 3, 0. And 2 times 2, 4. It gives you 3. The first row by the second column. We get 1 times 0, 0. 0 times 1, 0. And we have 2 times 4, which is 8. So this guy is 8. Let's move on to the second row. Here we have the product 3 and negative 1, negative 3, plus 2, negative 2 and 3, negative 6, and 1 times 2, which is 2. So here you have negative 9 plus 2, which is negative 7. Okay, perfect. Now let's move on here. The last row and the last column. 3 times 0 is 0, and negative 2 times 1, minus 2, and 1 times 4, which is 4, which is 2. Now we're going to just multiply these two matrices. The outcome is going to be 2 by 2 matrix. Very good. So the very first row, the first column, you get 3 and plus 14, which is just 17. The first row by the second column, 8 minus 4, which is 4. Then the second row by the first column, you get 6 plus 7, which is 13. And finally, the second row and the last column, gets 16 minus 2, which is 14. So this is A multiplied by BC. Now let us multiply AB and then find the product with C. Here we go. 1, negative 2, 2, negative 1, multiplied by 1, 0, 2, 3, negative 2, 1. And then we multiply that by this matrix, 2 and 4. So let us start. This is a 2 by 2 matrix, and this is a 2 by 3 matrix. So we expect to get a 2 by 3 matrix, 2 row and 3 column. So 2 row and 3 columns. So very good. The very first row by first column, you get 1 minus 6, which is equal to negative 5. Then the first row by the second column, you get 0 plus 4, which is just 4. The first row by the last column, it is 2 minus 2, which is 0. Then we move on to the next row. Next row multiplied by the first column, you get 2 minus 3, negative 1. Then we have 2 times 0, 0, plus 2, which is 2. And this guy multiplied by the last column, which is 4, minus 1, which is 3. Now we're going to multiply this guy by negative 1, 0, 3 and 1, 2 and 4. A 2 by 3 matrix and a 3 by 2 matrix. So we expect to get a 2 by 2 matrix. Let's see. The very first row and the first column get 5 plus 12 plus 0, which is 17. The first row by the last column, we get 0 plus 4 plus 0, which is just 4 as we see. Then the second row by the first column, we get 1 plus 6, which is 13. So far, so good. And then negative 1 times 0 is 0, plus 2 plus 12, which is 14. So we can actually see this equality or the associative property for multiplication is satisfied here. These two are equal.